Okay, Yashovardhan, I've got your message also. So I'll start with the HC Verma doubts. Question 31. Let's start with this. Okay, just go through the question, all of you. Jitesh, I've got your doubts also, and Jinendra, your doubts also. So anyhow, I'm just starting with this one. So just go through the question if you have it, if you have HC Verma in front of you right now. Okay, so I'm just mentioning the question. Okay, so it says that an elevator is descending with a uniform acceleration. To measure the acceleration, a person in the elevator drops a coin at the moment the elevator starts. The coin is 6 feet above the floor of the elevator at the time it is dropped. The person observes that the coin strikes the floor after 1 second. Calculate from the data the acceleration of the elevator. Okay. So though this question can be done very nicely by using a concept called relative motion, okay, but here we will solve it using the regular concept, not the relative motion idea. Okay. So let us say this is the elevator which is having a uniform acceleration A downwards, which you don't know. Okay. Now a person drops a coin. So at t equal to 0, that person drops the coin. And after some time, the coin hits the floor of the elevator. Let's say by the time it hits the floor of the elevator is moved here. Okay, so this is the position of the elevator at t equal to 0. Now by the time it hits the floor, the position of the elevator is here. The position of the coin is here. It's hit the floor of the elevator. So you can see here that this is the displacement of the coin. And as far as the coin is concerned, it has a downward acceleration equal to g. So in that time is given as, I think, 1 second. Okay. The displacement of the coin is half gt square. It starts from rest. Okay. Now during that same time, the elevator is also making a displacement like this. And the acceleration of the elevator is downward and equal to a, which we don't know. So the displacement of the elevator, yes. What happened, beta? Now it's also given to you that the height from the floor of the elevator from which it drops it, that height is equal to 6 feet. So now you can see here that the value of t is equal to 1 second. Okay. And the difference of displacement of the coin minus displacement of the elevator should be the height. Okay. So half of g minus a into t square should be equal to this height. So half of 9.8 minus a into 1 square should be equal to the height, which is given to us as 6 feet. So convert that 6 feet to to meters. Okay. So the conversion unit from feet to meters is approximately 3. Okay. But like 1 meter is equal to 3 feet. Okay.
3.2, sir.
Slightly more. So anyway, like when you convert from feet to meters, 0.305 approximately. Okay. So from this you will get the value of E. Okay, so this question is clear. Now later we will understand this motion, this question by using another method called relative motion. But right now, solving it by this method, you can see that the coin, as it goes down with an acceleration of g, during that same time the elevator is descending with an acceleration of e. Okay. So while the coin is released from 6 feet above the floor, but the floor of the elevator would have displaced downwards. So actually the coin is having a displacement of more than 6 feet, such that the displacement of the coin minus the displacement of the elevator's floor, that is equal to the height h from which it was dropped. Yes, Vedant, I have got your message also. That is for HC Verma, right, Vedant? Question number 45.
Yes, sir.
Okay. So we will do that also. Okay. So next up, we'll do question 34. And then after 34, we will look at 42 and 45. These two will be the next two questions. From HC Verma, that is. Okay, so just go through question 34. Okay, let's look at question 34 next. So it says in a soccer practice session, the football is kept at the center of the field, 40 yards from a 10 feet high goal post. Goal is attempted by kicking the football at a speed of 64 feet per second at an angle of 45 degrees to the horizontal. So the problem in this type of question is just the conversion of the units. Okay, so anyway, so the distance from which we are kicking the ball is given in yards, and the height of the goalpost is given in feet, and the speed of projection is also given in feet per second. So we have to find out if this happens or whatever. It's 40 yards distance, 10 feet high goalpost, and 64 feet per second speed. So this distance D here is 40 yards. This height of the goalpost is 10 feet. The speed of projection is 64 feet per second, and the angle of projection is 45 degrees. So what we can do here is take the FPS system of units, that is foot pound second type of system, instead of taking SI system. Okay. So that way you will only have to convert one of the things. Okay. You have to convert yards to feet. Okay. and 1 yard is equal to 3 feet. So per second square, and you convert this to foot per second square. The value is about 32 foot per second square, 32.17. So we can just take it. Okay. So now what you can do is the easiest way to solve this is write the equation of trajectory. This is x and this is y. The equation of trajectory, the projectile. Just remember this form, it is easier, where r is sine 2 theta divided by g. So here tan theta is equal to tan 45, which is 1, and r is 64 square into sine 90 divided by 32. So that is 128 approximately. So your equation of trajectory, this one, this becomes y is equal to x into 1 minus x by 128. So now the point where the ball crosses the goalpost, assuming it crosses the goalpost, let's say that point is this point here. So it has coordinates, let's say a comma b. So at the point P, which is a comma b, the value of b is unknown, but the value of a is the x coordinate. So it is how much?
120 feet.
120 feet approximately. So substitute this here. So you get b, which is that height of that point, is 120 into 1 minus 120 by 128. So that is 120 into 1 minus, now we can divide this by 4, for example. So 450 divided by 2, so further divided
1
by,
by 15, sir. It's like 120 into 1 by 15.
yes, this will become 120 by 16, correct? So 30 by 4 or 7.5 feet. Okay. So you can see that it will basically get netted because it is less than 10 feet, unless of course the goalkeeper is able to stop it. That's a different matter. So it not only reaches the goalpost, but it reaches at a very optimal height of 7.5 feet. Yes, exactly, Vedant. That is the point, that when x is equal to 120 feet, the value of the y coordinate should be less than 10, but at the same time greater than 0. Okay. So we want this situation which I have shown in the diagram, where it is less than 10, but at the same time it's not like this. Had the trajectory been like this, then at x equal to 120 feet, it would have shown y as a negative quantity, which is what we don't want, because we don't want the ball to bounce before the goalpost. Or on the other hand, it could also be like this, that it's more than 10 feet, so it's missed the goalpost. So the correct trajectory we want is something like this, and this is providing the correct trajectory, because you can see. Okay. So hope the usage of equation of trajectory is clear to all of you. If you've attempted this question before using the time-based equations, you will realize that that will give you the same situation, but it will take longer to solve. The equation of trajectory is the very efficient way of solving these type of questions. So you have to get used to this. Okay. Experiment with different types of methods of solving questions, whatever comes to your mind when you're doing these type of questions. It will help you. In practical conditions, it wouldn't matter in the sense that, see, the thing is like you want to make a direct score, no? So you don't want the ball to be intercepted before the goal. So in that sense, no, there will be defenders and all present before the goal post also. Got it, no? So anyhow, so then it becomes debatable. If it's less than 120 feet, the range, then whether or not the goal will ultimately get scored. But in this case, there's a high probability unless the goalkeeper stops it. Let's just say we want to directly score the goal and there's no goalkeeper. Then this is the condition. Okay, let's move on to next. We are doing what, question number 42, I think, right? 42, then 45, then 46, sorry, 47. Right. So let's complete these questions, then we'll come to the worksheet next. Okay. 42, 45, and 47. Go through these questions, we'll discuss. Okay. Yes, I'll just give some time for you to note down this part if required. But in the meantime, those who have finished, just go through question 42 and 45 next. We're going to discuss those.
Sir, I have a doubt on 36 too.
36 also, okay, we'll discuss that. Okay, then go through 36 next, we'll go through that. In 36, now see what is happening. Your length of the motorbike is also given. Na? .7 feet wide ditch with approach angle 15 degrees. No, length of the motorbike is not given. Okay. So then we should just take the range as.
Sir, it is given.
It is given, sir. 5.
Given in the next line, na?
Yes.
Yeah. So the range should now become 11.7 plus the length of the motorbike. You understanding, na? That's the trick in the question, because see, when the bike, okay, bike is 5 feet long, okay. So you will, if you think of a detailed diagram, no, it will be something like this. This is your ditch. Now, if the bike starts from here with you, okay, at an angle theta, we wanted to land safely on that side. So the rear wheel of the bike should be past the ditch. Okay, and this angle theta 15 degrees is pretty small. So what we'll have to take is the range of the bike. We'll have to take as this. From this point to this point, we'll have to take the range. So that range will become the length of the ditch. So let's say D plus the length of the bike, which is, let's say, L. So we want the range to be greater than equal to 11.7 plus 5 feet. So we want basically that the range should be greater than equal to this. And the angle of projection is 15 degrees. And take G as 32 feet per second square. So U square sine 2 theta divided by G, that is the range, should be greater than equal to 16.5 feet. Okay. So U square sine 30 divided by 32 should be greater than equal to 16.5. So solve this for U. So you will get a condition that U is greater than equal to a certain quantity. Okay, understood now, this 36 question?
Yes, sir. Yes.
Okay. Did you take the range as 11.7 and try to solve?
Yes.
Okay, so now understood the difference now, why the length of the bike is given, so that you have to include that.
Yes. Yes.
Okay. Right. So moving on to 42nd question now. Go through that. We will discuss. So 42nd question, basically you have to apply the condition that you have to miss the second corner of the second step. Okay. So that you land on the floor below. You should not land on the first step. You should not land on the second step. You should land on the floor below. So So basically, if you miss that second corner, which is there in the diagram, so that means when your y coordinate is 10 plus 10, 20 centimeters downwards, at that moment, your x coordinate should have become more than 20 plus 20, 40 centimeters. Okay. So for this also, you can generate a special equation of trajectory. Okay. Yes, yes, you can do that, Jitendra. You can draw that imagine, or you can use time-based equations also.
Sir, we can like draw dotted lines, then find the range of that ball at which it will take down.
Yeah, but more important than the range, no, beta, is that
Yeah.
when your y coordinate, I mean, when your vertical position is alongside the second corner,
Yeah.
the second corner point, at that time your horizontal displacement should be more than 20 plus 20, 40 centimeters, so that you miss that point. So that is the
Okay.
condition you have to apply.
Yes.
No? So you take
Yeah.
your y-axis downwards. When your y is equal to 20 centimeters, that is you are at the same level as the second
Yeah.
corner. That time your x coordinate should have become more than 40. So just apply that condition
Yes.
and try to get the answer all of you. Okay. I'm not making the diagram straight away. I want you people to try and solve it yourself. I'll just make it in a minute. Okay. Try to work it out from what I'm saying. Is getting the answer, anybody? Okay, so continue working on it. I'm just making the diagram. Okay, Om, I'll pick up the 35th and 40th question also.
Sir, I have sent you the answer.
Okay, yes, very good, Jimmy. Okay. So I've projected at a speed u like this at time t equal to 0. Now let me take this as my x-axis and this as my y-axis. So what I want is a trajectory which is like this. This is the trajectory I want. This is not the trajectory I want. This is not the trajectory I want. So you can see that when it is at this point here, let's say this point, its x coordinate should be greater than,
Sir, is 4 the answer?
just check now, beta. Okay, I'll just verify it for you. Whereas its y coordinate at that moment is how much? It is 20 centimeters. So it has to miss this corner point. Okay, so its x coordinate has to be greater than 40 centimeters at the moment when the y coordinate is 20 centimeters. Okay. Now I can also write time-based equations here, which is very easy actually. So I can see that in general, x is equal to ut and y is equal to half gt square. So it implies that y is equal to 20 centimeters at t equal to square root of 2 into y by g. That is square root of 2 into 0.2 divided by 10. Let's take g as. Okay. So that time will come out to be 0.2 seconds. So at that instant, I want that the x coordinate u into 0.2 should be greater than equal to 0.4. So u should be greater than equal to 0.4 divided by 0.2. So u should be greater than 2 meters per second. Just check, this should be the answer.
Yes, sir, it's the answer.
Because I've taken G as 10. I'm not sure if HC Verma has asked you to assume G as 10. You take 9.8, you will get a slightly different value. So
So we could have taken HS 30 also, right?
we could have taken which one? H.
Height is as 30 also.
No, but then see, that is the time when it's reached the ground level. Okay. But for the ground level, the condition is different. No? For you understanding? No? You have to make sure that you miss this point. No? So the difference between this trajectory and this trajectory is here only. No? When the level is this. You understanding?
Yes, sir.
At the ground, you cannot guess how much the horizontal should be. It's not only greater than 40, but it's much greater than that, no? Because it has to go in a path like this, right? So how do you know what is this minimum distance you have to cover? Because it's missing this point and coming to a point which is more than 40 centimeters. No?
Yes, sir. Yes, sir.
So the critical point is this corner actually. So once you avoid that corner, you know that anyway is going to reach the ground level. Okay, so that was the 42nd question. Now we'll go back to question 35 for a moment. Okay. Then we'll come back to 45. Okay, so 35 question is about that
Goli
game,
game.
which Gulli Danda or Goalies it is called. Okay. Small glass ball called goalies. Actually, not Gilli Danda. This is goalies actually. So you're throwing those small spherical glass objects, small goalies. Okay. So you have to hit another one of those goalies with the goalie that you're projecting. So you're projecting the goalie from a height of 19.6 centimeters from the ground. It has to be projected horizontally, and it is at a horizontal distance of 2 meters. So it's again a case of horizontal projection from an elevated point. So let's say this is your ground level. This is where the first person's goalie is, let's say that is A, and the second person is projecting his goalie from a point which is at a given height and at a given distance, but he has to project it horizontally so that it then goes and hits this. So the meaning of the question is clear, Om?
Yes, sir.
Okay. So now again you can do the time-based equations here to be easy. So take this as your x coordinate, take this as your y coordinate. So if he projects it at t equal to 0 and goes and hits the goalie A at time t. So at t equal to t, what should happen? Your x coordinate should become d. So ut should become d, and y coordinate should become h, or half gt square should become equal to h. So substitute the value of t equal to d by u here. So you get the condition on this. So you get that u square should be equal to gt square by 2h. So u should be equal to square root of gt square by 2h. So this distance is 2 meters, and the height from which we are projecting is given to us as 19.6 centimeters. So I think it is better to take the value of g as 9.8 in this. Instead of 10, take g's value as 9.8. So this will become your projection velocity in meters per second.
Yes, sir.
So कितना हो जाएगा? I think it will be 10 meters per second, right? Okay, finish up this question. This was question 35. Next up, we're coming to question 40 and 45.
Sir, 47 also.
Okay, 47 also. So go through 40. We'll discuss that next. Especially the second part of the plane, the question is very interesting. That if the plane is flying with uniform speed but not horizontally, that means it has a sort of oblique kind of speed. Even in that case, when the plane drops a bomb, you have to show that the bomb will explode at a point which is vertically below the plane. The main thing you have to understand in this type of question is that when you drop a bomb from a moving plane, okay, the initial velocity of the bomb with respect to ground plane is same as the speed with which, or the velocity with which the plane is moving, because you dropped it from the plane. So with respect to the plane, it is at rest, but the plane is already in motion with some velocity v. So that velocity v, whatever it is, whether it is horizontal or oblique, that velocity of the plane becomes like the initial velocity of the starting point from which the bomb starts its projectile motion.
Sir,
Exactly the point, Vedant. That is what you have to consider. That because of the property of inertia, so the bomb is already inside the plane, moving with the velocity that the plane has. So when you drop the bomb, it retains that momentum. Now, the
sir,
moment you release the bomb, there is gravitational force, so that momentum starts changing, but the initial momentum will be the same as the momentum it had because of the motion of the plane. Yes.
sir, so from 40th we can say 40th sum we can say that now that pilot will see the bomb below his plane only, like when he will
Yes,
drop.
yes, yes. Exactly. You will always see the bomb to be falling vertically. So in 40th question, the first part, if we assume that the plane is moving with a horizontal initial velocity, okay, and at t equal to 0, let's say he drops the bomb. So the bomb is dropped. So the bomb also has the same horizontal velocity. So after some time t, when by the time the plane has reached here, okay, you'll see that in its trajectory, the bomb would have reached here. Okay, so with respect to the pilot, it will look like it's only having a vertically downward displacement. So x for the plane will be equal to x for the bomb, will be equal to ut. But y for the plane will be 0 because the plane is balancing the gravitational force with airlift, okay, or with the thrust force generated, and y displacement for the bomb is equal to half gt square. So this displacement will appear to be equal to half gt square. So second part of the question, yes, even if the plane is moving obliquely, so let's assume in one case the plane is moving like this. So when the bomb is dropped, at that moment the bomb has got the same initial velocity. So after some time, as the plane reaches here, the bomb might have had a trajectory which gone like this. So by that time, by the time the plane reaches here, let's say, the bomb has reached here. So once again, you can see that taking this as our x-axis, and suppose we take this as our y-axis. So we can see that for the plane, the x component of displacement is u cos theta t. The y component of displacement is u sin theta t. For the bomb, the x component of displacement is u cos theta t. The y component of displacement is u sin theta t minus half gt square. So this height difference at which the pilot observes, this will be equal to the difference in the y coordinates, which will be half gt square. So once again, you will see that the pilot will always see the bomb to be vertically below him and exactly at a distance of half gt square below. Whereas this diagram that I'm showing you is what the ground frame observer will see. This observer who's at rest on the ground, he will see the plane moving along this line, okay, and the bomb falling along this line. So even by the time the bomb falls on the ground, the plane is vertically above it. Assuming that the plane moves with uniform velocity. This is uniform. Okay, so hope the concept is clear for the 40th problem. Okay, so next we are moving on to 42nd question. Oh, sorry, 42nd we have done already. We're moving on to 45th and 47th, right? 47th, you might have to wait a little bit. We'll discuss relative motion and then do. Okay. We just recall what the question is.
Sir, for 47th.
Yeah, 47, you'll have to just wait till we complete relative motion.
So,
Okay.
Okay. Yeah.
sir, after means 47th question onwards, all the questions we need to do later on once you teach relative motion.
Yes, yes. In fact, I will be teaching part of relative motion today itself. Okay. But I will tell you when to do those questions. Instead, today I'll be giving another exercise on projectile motion and also revision of one-dimensional motion. So
Sir,
this week you will do that.
So actually, we had the worksheet, but I couldn't complete it full. I had done HC Verma, but
Yeah.
the worksheet I couldn't complete it. I have started and I have done a lot of sums from that.
Yeah. So this coming week now. So anyway, I think your major test is now postponed to 19th, right? So you have some time.
Yeah,
So
yeah.
so before 19th, like you will complete the worksheet I've given in projectile motion, plus I'll be giving some more revision worksheets in 1D plus projectile motion. So all this you have to complete in the coming 2 weeks. Okay. Okay, now go through the 45th question we'll discuss. So the main thing in the 45th question is again the diagram. Okay, you have to understand what the geometry of the diagram is exactly from the language of the question. So try to follow it and make a diagram properly. The length of the boat is given, distance is given, and all that. But how the boat is placed with respect to where the person is standing, that is the main thing you have to understand. Okay, so it says that he is in line with the boat. Okay, so that means he's no, when he throws the projectile, it will be a plane in which the x-axis, the horizontal axis, is the same as the axis along which the length of the boat lies. Okay. So the situation is something like this. If this is the water surface, and this is, let's say, the boat. So now he's standing on the shore somewhere here, so that the length of the boat is along his x-axis. Okay, very good. So one case is, let's say, alpha, when he throws and the ball just about reaches here. So this alpha will be the minimum case. And another case will be when he throws like this and it reaches there. Let's say this angle is beta. Beta is the maximum case. So take u square sine 2 alpha by g to be equal to d. So we'll get alpha as the minimum angle. And take u square sine 2 beta divided by g as d plus the length of the boat. You get beta as the maximum angle. So to solve this, just take the values now, you will get the answers.
So here D would be fine, right?
D would be the distance from this thing.
So it says
this
from the center, so it would be fine.
Yeah,
If we
he's
take it from-
1 meter long boat and 5.5 meter from the center. Yeah, so it would be 5. That's correct. Okay. From the center of the boat, he's at a distance of 5.5. So this distance here is 5.5. And the boat itself is 1 meter long. So this is 0.5, this is 0.5. So this would be substituted as 5. This would be 6. So this equation would tell me that alpha is 1 by 2 sine inverse of 9.8 into 5 divided by
It would be better if we take it as 10.
So 10 के साथ
Okay.
we get direct.
10
We get
divided by
50.
what is okay. U is given as what?
10 meter per second.
10 meter per second.
10. This is half of sine inverse
U
of
square,
half.
right?
Yes. Okay. So half of 30 degrees. Okay, and from this you will get beta as half of sine inverse of 0.6, you know, is 3 by 5. So it's 37 degrees half. 18.5 degrees.
Sir, behind the answer is given that maximum angle is 75 degrees. And that there is an interval.
Oh, wait. I'll explain why that is the case. Now, see, the thing is, you also know that the range repeats. At whatever range you have at theta, you have the same range at 90 minus theta. No?
Yes, sir.
So, the maximum theta will be actually 90 minus alpha, because alpha is the smallest angle.
it also says that there's an interval of 53 degrees where you will miss the shot.
So I'll explain to you what that means. So see, the thing is now, if we project at any angle alpha, okay, where alpha is greater than equal to 15 degrees, okay, then the range that we are getting, so alpha is greater than 15 degrees, okay, but less than 18.5 degrees, okay, then you're getting a range like this. Okay, so this is the case. Okay. Now also, if you project at an angle of like this, now if theta is equal to, for example, 90 minus 15, that is 75 degrees, you're getting the same range. Okay. Now, what if you project at an angle of 90 minus 18.5 degrees? You'll get a range like this. So this is how much? This is 73.5 degrees. Okay. So again, for theta between 73.5 degrees to 75 degrees, you're fine. Okay. And for theta between 15 degrees to 18.5 degrees, you're again fine. But in between, if your theta is between 18.5 degrees
Sir,
and 73.5 degrees, then you're not fine.
sir,
So
I
this is
believe
the
it is 71.5 degrees.
90 minus, yeah, sorry, 71.5. So this value is
Can you explain
71.5.
again why 75 degrees? Okay, like allowed for the range.
Okay. So see what happens is that the range repeats at two angles. When we project an object at a certain angle, suppose theta, okay, where theta is less than 45 degrees, suppose. So the range is what? U square sine 2 theta by g, or ux into t. So that is 2u sine theta cos theta divided by g, or ux is u cos theta into 2u sine theta divided by g. Now if I project the same thing with the same speed, but
Sir,
at an angle like this, yes.
sir, ux is, I believe, u cos theta t, no?
No, beta, that is the x coordinate. Ux is the x component of velocity.
Okay, sir.
So in this case, the range repeats itself. Okay. So if you replace projection angle as 90 minus theta, so now what happens is your projection velocity is u cos 90 minus theta, which is u sine theta, and your time of flight is 2u sine 90 minus theta divided by g. So it is 2u cos theta by g. But your range, which is ux into time of flight, that remains the same.
Okay, so understood.
So for example, if you project something at u equal to, let's say, 50 meters per second at an angle of projection of, let's say, 30 degrees. So your range is what? It is 50 square into sine 60 divided by 10. So it is 250 into root 3 by 2. So it's 125 root 3 meters. Okay. Now the same thing, if you now project at the same speed u equal to 50 meters per second, but at an angle of 60 degrees, you'll see you'll get the same range. it becomes 50 square sine 120, and sine 120 is the same thing as sine 60. So you get the same range. So why this happens is here it is ux into t, so that ux is 50 cos 60 degrees, and the time of flight is 2 into 50 sine 60 divided by g. Here the same thing, they are getting interchanged. It is cos 30 oh sorry, here it was 30, here it is 60 anyhow. So it's 50 root 3 by 2 into 100 into half divided by g. So here it is 50 into half, but the second term is 100 into root 3 by 2 divided by g. You can see that this value is equal to this value. Yes, exactly. So the range is equal at complementary angles. So for every value of range, there are two angles of projection other than when theta is 45. So range at theta is equal to alpha is equal to range at theta equal to 90 minus alpha for a given u. So that is why range at theta equal to 15 degrees is the same as the range at theta equal to 75 degrees. So if in one case I want theta to be greater than 15 degrees, then on the other side I want theta to be less than 75 degrees. And again, the range at 18.5 degrees is the same as the range at 71.5 degrees. So if I want theta to be less than 18.5 degrees, I also want theta to be greater than 71.5 degrees. So if you combine these two statements, you can see that overall theta should be between 15 and 18.5. Okay. Or for the higher values, it should be between 71.5 to 75 degrees. I'll explain this with a diagram also, but try to understand this from the formulae above.
Sir, sir, I have a doubt. You said if theta is between 18.5 to
71.5.
71.5, it won't
It
be
will
like,
not.
it will
Let me explain how that point works. Okay. So see,
say that it is only 53 degrees.
No, not 53. Let me explain. Okay. So see, if I project here at 15 degrees, okay, it's just about going and hitting here. So if I project at less than 15 degrees, it's not going to work. Okay. So theta equal to 15 degrees, the range is 5 meters. Okay. Theta less than 15 degrees, the range is less than 5 meters. So this is not going to work. But the complement of this is like this, that if I project at theta equal to 75 degrees, the range is 5 meters. But if I project at an angle larger than 75 degrees, and go up to a greater height, but it will. So theta greater than 75 degrees, the range will become less than 5 meters. So this will also not. So the other end of the spectrum is when I wanted to hit the other side of the board. So if I'm going for small angles comparatively, I have to go for 18.5. I go for 18.5 degrees, just about hits here. So the range is equal to 6 meters. But if I go for an angle greater than 18.5, then it's going to miss it. I don't want this. Now similarly, look at the complement of this angle. It's like this. If I project at 71.5 degrees, it's just hitting here. But if I project at less than 71.5 degrees, it's going like this. So now when you combine these statements, you will understand that the theta has to be either between 15 degrees and 18.5 degrees, or theta has to be between 71.5 degrees but less than 75 degrees. So these are the two ranges of theta for which you will be hitting that region which is between 5 meters and 6 meters in range. Is it clear now?
Yes,
Yes,
sir.
sir, yes.
Yeah, yes, I'll show the upper part also. Yeah, that is given in the question. Yes, that the speed of projection is consistently the same in all the cases. So with that particular speed of projection, what is the range of angles at which we can project? so that we are able to hit that board. So every time we are projecting with the same speed, but we are adjusting the angles. So in what kind of adjustment of angles will we be able to hit that particular board? So for the adjustment of the angles, either our angle has to be in that range between 15 and 18.5, or it has to be that range between 71.5 and 75. Okay, I'll yeah, moment. Yeah, tell me, Yash, which part? This part? The question before this, the 40th question? Question 45 only, yeah. So this is the original diagram of question 45, but the full explanation of the solution I've given below. Okay, very good. So I think with this we finish the doubts from HC Verma, right? For the moment, the couple of doubts that people have asked from the worksheet, projectile motion worksheet. So I'm just going through that and we'll discuss. So question 24 from the projectile worksheet. That is a question that yes, you have asked, and Jitesh, you have asked a couple of questions, which are also I think from the worksheet only, right? Anyhow, so
Yes.
we'll discuss these. Jinendra, you have asked question number 1, 18, and 20. Okay, so let's start with this. So projectile motion worksheet, we'll start with question 1 and 18.
Sir, 17 also.
Okay. Question 1, 17, 18, 20,
Sir, in
24.
17, I have done the A part, but in B part, in finding the impact velocity, I'm like not clear about it. So
Okay,
this
okay, we'll discuss. Don't worry.
conceptual thing is there. So
Okay, so far these are the questions that I have received from the worksheet. Okay, if anything has to be added to these questions, please let me know. Okay, just a moment. I'll switch to the worksheet. Projectile motion worksheet. Okay,
sir, 15 also.
15 also. Okay. Okay, so I'm just switching to the worksheet. Yeah, so question number 1, let's start with this. So it says that in 3.5 hours, a balloon drifts this much north and this much east and this much upward in elevation from its release point. Find the magnitude of its average velocity and the angle its average velocity makes with the horizontal. Okay, so this is a very nice question, which is not so much about projectile motion. It is just about the concept of average velocity and displacement. Okay, so one thing you have to understand that north and east, they both lie in the horizontal plane. They're not vertical. They are both in the horizontal
Sir,
plane.
we have to use the application of vectors.
Yes,
So we
3D
can write
vector.
with vectors. Yes,
Exactly. Just make the 3D vector component kind of thing, you know, like I'll explain. So now generally the thing that people get confused with is that they get confused between north direction and vertical direction, wrongly assuming that they are the same thing. Okay, that's not the case. So let's say this is a horizontal plane. So this is some part of the Earth's surface. And in this, if you put a compass, suppose it points like this. So this is your north direction, this is your south direction. Okay. So then obviously this is your east direction and this is your west direction. Okay. And your gravity in this is pointing like this. So your vertical direction is this one. So what you can do here is you can take the direction going from west to east as your x-axis, and take the direction going from south to north as your y-axis. So immediately the direction going vertically upwards will become your z-axis. So z-axis is vertical, y-axis is pointing towards north, okay, and x-axis is pointing towards east. So now the balloon, let's say it starts from here at t equal to 0. So after some time it reaches somewhere here, where the x component of its displacement, the y component of its displacement, and the z component of its displacement are known. Okay. So it reaches a point where the x component of displacement, it has gone from the origin of my coordinate system to the point P, where the x coordinate or the distance moved along the east is 9.7 kilometers. Okay. The coordinate along the y-axis or along the north is 21.5. And the vertical coordinate, that the height it has reached from the ground, or the elevation what they are calling, that is 2.88 kilometers. So during this, and this is during a time interval of 3.5 hours. So the displacement is 9.7 I cap plus 21.5 j cap plus 2.55 k cap. This is the displacement in
2.88, right?
kilometer. Yeah, sorry, 2.88, my mistake. So this is in kilometers, and the time is this one. So for example, the average velocity is just that displacement divided by the time. The magnitude of average velocity will just become the magnitude of displacement divided by the time, like that. Okay. So this is the time, this is the displacement. So from that you will get these two things. Okay. Now one more thing the question is asked is, so magnitude of its average velocity, the angle that the average velocity makes with the horizontal. Now this is a very interesting thing. The angle that the average velocity makes with the horizontal. So for that you have to understand that if you look at this as your vertical axis, then your displacement S is at some kind of angle like this with the vertical axis, let's say alpha. Okay. Or if you have studied about the concept of direction cosines, this angle is called gamma because this is the z axis. Okay. So the angle that it's making with the horizontal is 90 minus gamma. Okay. So you have to be able to visualize this in 3D actually. Okay, it's something like this. In 3D, this is your x, y, and z axis. Now your displacement is a vector which is something like this, let's say. Okay. So if you drop a perpendicular on the z axis, this is the z component of displacement. This angle is gamma. But if you drop a perpendicular on the horizontal plane, it's like this. Like this. So this is the angle that we are looking for. We are looking for this angle theta. So that is basically 90 minus gamma. And for gamma, you know the formula that cos gamma is going to be the vertical component of displacement divided by S. It is going to be Z upon root of this thing, x square plus y square plus z square. So now your theta will be 90 minus 1. Okay, so hope the method is clear to all of you for calculating the angle made by the displacement or average velocity, whichever of the two you're looking at. Okay. This could be displacement, this could be average velocity. They are one and the same thing because they're collinear vectors. They're lying along the same axis, the same direction. Okay, so people, I hope this question is clear, especially this second part. Yeah.
So when we say horizontal angle in 3D, it means horizontal plane, xy plane.
Yes, yes. With respect to the horizontal means with respect to the horizontal plane. So from the displacement vector's head, now, if you drop a perpendicular directly onto the horizontal plane, you see you're getting this right angle triangle which I've drawn with the dotted lines. Okay. So that angle theta we want to find. So that angle theta we cannot find directly. Rather, we can find the angle with the vertical directly using this formula. Okay. And then we can subtract 90 minus that. Okay.
Yes,
So I'm not completing the calculation. Yeah.
Yes, I was confused in that only because like horizontal in 3D we have three different angles. So horizontal क्या होगा वैसा?
Exactly. You have alpha, beta, gamma, but it is neither of those three. No? It is in fact 90 minus gamma. So that's the thing.
Yes.
Okay. Let's move on to then 15th question, right? That's the next one which we have in order. That's a 9th question also. Okay. So let's move on to 9th question. Then we'll come to 15th.
So 9th requires some very different angles, का sine and tan.
So we'll use calculator for it. Okay? Don't worry. Okay? But actually 26 degrees is not that different from 30 degrees. So if you just approximate it as 30 degrees values and try the question, you'll get reasonably close answers.
Yes, like I took the calculator thing and still answer was close only because I like बहुत round off to do. If we take
So
20.
take this as 132 feet per second. This 26 degrees, you take sine theta is approximately half only, and cos theta is approximately √3 by 2, or approximately 0.5 and 0.86. And take the value of g as 32 feet per second square while doing this question. Okay. So basically, I'll just show you the diagram. So the ball is hit from 3 feet above the ground level. Okay, and you're trying to catch it at a distance of 386 from the position from which it is hit, that is the home plate. Okay. So how high above the fielder's glove it will. So you can again solve it using that equation of trajectory, only substituting the values might be a little tricky. So you're hitting it from 3 feet above the ground.
Sir, I have done that, but not by trajectory.
Okay. So when it reaches here, so again, what I'll do is I'll take this as my x-axis, take this as my y-axis. Okay. Now let us say this is where the bleacher wall is. Okay. And the x-coordinate of that wall at that instant is given to me as 386 feet. Yes.
Sir, I just wanted to ask you one thing that means, are you adding something?
Yeah, you can see now.
No, sir.
Sir,
Not
no.
appear.
Visible.
Ajay, now you can see.
Yes,
Yes.
now.
Okay. Okay. Right. So you're hitting the ball, which is 3 feet from a position which is 3 feet above the ground level. So that point I've taken as the origin, and from there the horizontal is the x-axis, the vertical is the y-axis. So this is your parabola, and this point where it's about to hit the wall, let's say that point is P. So this point's coordinates are such that A is equal to 386 feet. B we need to calculate. And once we calculate B, we can see that the fielder is at 7 feet above the ground. So that means the fielder's coordinate, let's say F, hand's position coordinate, the Y coordinate is how much? It is actually 7 minus 3
4.
of 4 feet. Okay. So you need to compare B with 4 feet. Whatever distance B is above 4 feet, that is the value by which he will miss it. Understood? No?
Yes, yes.
So
So
you
you
again,
use projectile.
yeah, use this equation where your theta is 26 degrees. So tan theta will be approximately 1 by root 3. And so that will be approximately. Now U was given to us as, is it now 132 feet per second. Okay. Sine 2 theta will take approximately as root 3 by 2 sine 60 divided by G, 32 feet per second. So this will be R in feet. Okay. So you get this value, and now in this you substitute X as A, which is 386 feet. So find the value of Y, which is B. And then your answer is that whatever your B minus 4 is, that is the distance by which he misses the ball. This distance. Okay. So it's calculation intensive, but otherwise, this is the method of doing the question. Now you can see you don't really have to solve anything huge. It's just the arithmetic part is little complicated. So you can use a calculator also, but it's better if you learn how to do the sort of approximate calculations yourself using these values. Anyhow, so this is 9th question. Next, what we are doing, we are moving on to question number 15, right? 15 and 17. Okay. Okay, so let's come to question 15. So this is the same question you sent me on text message also. So muzzle velocity is this much. So muzzle velocity basically means what? The velocity with respect to the muzzle of the gun, or the muzzle of the gun is like, the pipe through which the bullet comes out. Okay, the
Yes.
channel of the gun through which. Okay.
Yeah,
So
yeah.
this much target is 150 feet away. How high above the target must the rifle barrel be pointed to ensure that the bullet will hit the target? So basically, you take as if the target is at the same horizontal level as the bullet, okay, as the firing point. So you want the range to be 150 feet. Okay. So for that, you have to aim at an angle theta which is above, no? So that your U square sine 2 theta by G is 150 feet. If you aim the bullet horizontally, then it will end up reaching a lower point. No?
Sir, from formula I tried, I got the answer, but like from basic formulas, I am not getting. Like
I'll explain.
R is equal to U square sine 2 theta upon G. From that I
So
got it.
theta, no? You got theta. No?
Yeah, I got it.
Now the main thing is from that how you will find the where you have to aim. No? Because where you have to aim is in terms of a distance above the target, not in terms of angle.
Yes, sir.
Got the point, no?
So
Yeah.
better we will take like horizontal projection from a height, because in a practical life also bullet doesn't goes in a parabolic trajectory. Actually, it like drops from its total height now. So
No, the
better
thing
will be
is, let me explain this point. Okay. That is if you have the option of going from a height. Okay. But suppose you are firing from this level. Okay, you don't have that option because you are on the ground. You understand?
Only so we will take our height as the height above the target which we are firing. So target is at the ground level. We are at H height. So फिर we will aim horizontally सामने.
But see, the question is not saying that you are at an elevated point. The question is saying that the target is in front of you at a certain distance. You understanding the point? So
Yes,
here you don't have the option. No? Your target is here only. It's at the same horizontal level and you have to hit it. And it's at a horizontal distance which is given to you. You understanding the point? No?
yes, sir.
So your your bullet, your muzzle of the gun has to be aimed like this. Like I'm showing a very exaggerated diagram. It won't have to be aimed so much higher, but it'll have to be aimed a somewhat distance higher. Let's take that distance as D, so that when you fire the bullet actually at that U, because of gravity, the bullet's path is like this and it hits the target. Okay. So I basically want to find that D. So it's all about trigonometry, na, as you can see.
Yes,
If
sir.
I can
But
find this angle of projection, then basically your D by R is equal to tan theta. So D will become R tan theta. So that's how much higher you have to aim. I'll see that this angle is actually very small. So we can also use approximation. Okay. Small angle approximation. Anyhow, so let's understand this first. So our speed of projection is 1500 feet per second, right? And our range is 150 feet. And that is the data which is given to us. And G's value we'll take as 32 feet per second square. So first we'll go about calculating this angle. And to calculate this angle also I will use small angle approximation. U square sine 2 theta by G is equal to R. So sine 2 theta is 32 into 150 divided by 1500 square. So that is 10. And 10. Very approximately, we can take this as 30 divided by 15,000. So 1 by 500. So 0.002. Okay. So you can see that sine 2 theta is 0.002. So which means that theta must be a very small angle.
Yes.
So when we have a small angle, we can take sine 2 theta as approximately 2 theta only, which is 0.002 radians. So theta is approximately 0.001 radians.
Sir, I did by this formula, like this method only, but I got the answer. But I wanted to do it with some other basic formula method, like from the three formulas which you taught basically.
So this in this actually only one formula is being used, range.
Yeah.
The rest is about the geometry of the problem. The maximum height, time of flight, those things we don't need only. So out of the three basic formulae, only one is required, the range formula. The only thing is that the values are such that in that range formula, we are able to take advantage of small angle approximation. If I
Okay,
did
sir.
not use the small angle approximation, what is the option I have? I have to use a scientific calculator. That also we can do. So here we can do an exact calculation first of all. So we can see that sine 2 theta, when we do an exact calculation, now let me do this. Okay, so if I do 32 divided by 15,000 instead of 30 divided by 15,000. So if I do that, I get a value like this. I get this as 0.00213. So 2 theta is sine inverse of 0.00213. So now if I do that calculation, so sine inverse of this, if I use a scientific calculator or a sine table, will come out to be in degrees. It will come out to be 0.122 degrees to theta. So that means theta will be 0.061 degrees. So if I convert that into radians, okay. So to convert into radians, you have 180 degrees is equal to pi radians. No? So 1 degree is equal to pi by 180 radians. Okay. So this will become 0.061 into 3.14 divided by 180 in radians. So let's see what that gives us. Okay.
So you can approximate it like 61.
That is
divided by 180.
yeah. So approximation is fine. I'm saying the only other option we have of solving
Yes,
is
sir.
known
It
to
is giving 0.001 radians only.
so you see you get 0.061 into 3.14. You divide that by 180. You'll get this as 0.001064, something like this. Okay, so that is as good as this, no? Is correct. Okay. Now this distance again I'll use an approximation. It is r theta, but theta if I take in radians, that is okay. So r is how much? It was 150 feet into 0.001. So that is 0.15 feet. Okay. So 0.15 feet is basically how much? It is 0.15 into 12. So 1.8 inches. So you can imagine the kind of precision that you need. If you're a sniper, no? You have to aim 1.8 inches above the target if your target is at the same horizontal level as you and 150 feet away to account for gravity. And of course, a real life situation, the sniper also has to account for wind resistance if there's a strong wind blowing and all that. Okay. So it's all physics actually, snipers.
Yes, sir. Sir, but in the point of calculation ease thing, we can
Yeah.
change that height thing, right? Because I did it from that way and two-step me I got the answer.
It will become an equivalent situation. So basically, if you project horizontally from that level above, you should have to project it from 1.8 inches above.
Yes, sir.
You'll get that same kind of situation. Okay, anyhow, so this was question number 15, right? Now
Yes.
let's move on. Yeah, next we are doing what, 18 or 17?
Sir, 17th का B part.
17B part. Okay, so let's switch to the worksheet. Okay, so stone is thrown horizontally from the top of a tower, hits a ground which is 18 meters from the base of the tower. Find the speed. So that you have done. Find
Yeah.
the speed of the stone just before it hits the ground. Okay. So see, you have found the horizontal projection speed, no?
Yes, sir.
So now along with that, the stone is falling through a distance 18 meters. So you have also found the time for which the stone has fallen.
Yes.
So in that time, what is the vertical component? It is GT.
Yeah. So, sir, we have to take vertical component and horizontal
Horizontal.
component, then
Yes. And
add
then take the
the.
magnitude of that. So
Okay.
you will have like UX I cap plus some VY J cap, where VY will be your GT. Okay.
Yes, sir. Then
And
we
then
have to
take
do under
square root
root
of
and.
VX square plus. Yeah. The
Okay, sir.
magnitude of it. Understood? Huh?
Yeah, got it. I will do it.
Okay, very good. So then next we move on to which question now? 20th, is it? Yeah, 17, 18, 20, and 24. Okay, so 18th question next. So do 18, then 20, and then 24. Okay. Switching to the exercise again. Let's go through the 18th question. What is the maximum vertical height to which a baseball thrower can go throw if the maximum throwing range is 60 meters? Okay. Now this is a very interesting question. See, what we mean by the maximum height and maximum range and all that. is that, see, the baseball thrower can again adjust the angle at which he's throwing, but he cannot throw faster than a certain maximum limit. Okay, so let's say the fastest throwing speed is u. So then in that case, with that projection speed of u, how will he achieve the maximum range? By adjusting the angle to 45 degrees. So u square into sine of 90 divided by g, that is equal to your 60 meters. So from that, you know that what is the speed at which he can throw. Now, next what he's doing is, instead of adjusting the angle to get maximum range, he's adjusting the angle so that he can throw the highest. That is, his maximum height should be overall maximum. So what do you think is how he should adjust the angle? You know, for maximum range, he should adjust the angle to 45. But for maximum height, vertical height, what should he adjust the angle? Just think about that and you'll understand the answer. How should he throw the ball at a given speed so that the ball goes highest? For him to throw it longest, he should throw at 45. But for it to go highest, what
Throw
angle
it
he should
straight
throw?
up. You throw it straight up.
Yes, exactly. You should throw it vertically. So your angle of projection should be 90. In which case the maximum height will be u square by 2g. Okay. So for the maximum range, you use the formula u square by g is equal to 60 meters. So from that you will get u square. Okay. U square is g into 60. Now adjust it so that you can throw to the highest maximum height. So for that your angle of projection should be 90 and your maximum height will be u square by 2g. So how much that will become? That will become 30 meters directly by comparison. Is it clear? How will get 30 meters as the answer?
Yes, sir.
So don't even need to calculate the value of u. What you can understand in this is that maximum range is u square sine 2 into 45 degrees divided by g, and that is given to us as 60 meters. That means u square by g is equal to 60. Okay. Now for h max, the angle of projection should be 90 degrees. So h max will become u square by 2g. So substitute this here. So it will become 30 meters. But for this, you should project vertically. So this is done now. Next, move on to question 20th. Try this question out, we'll discuss. Okay. Try to use equation of trajectory here. See if you can use equation of trajectory.
Yes, sir, I guess I got it. But like,
Okay, so in equation of trajectory, you can use that fact that when you reach the maximum height, the horizontal distance is, yes, very good. It's tan inverse 4. Goodness. The horizontal distance is half the range. No? So now you use the condition that, so in equation of trajectory, one minus x by r. Now, when you reach the highest point in your trajectory, that point's coordinates are basically x equal to r by 2, y is equal to h. So from this, you will understand that the relationship between h and r is like this, r by 2. So h is equal to r by 4 tan theta. So now in this, you put the condition that if h is equal to r, you can see that tan theta is equal to 4. So it should be tan inverse 4. So the angle of projection for this situation should be tan inverse of 4 for the condition that maximum height is equal to range. You can also get this from formula. Okay. For maximum height and range, just use that formula.
yes, sir.
So that completes that. Next, we are doing question 24. So let's come to that. Yes.
Sir, can you repeat what is acha, okay, sir, yes, got it.
Just put h equal to r in that box formula. So you'll get
Yes,
tan theta equal to 4. Okay, 24th question involves some extra terms and all. So don't worry what a cathode ray tube is. Basically, it's a tube through which electrons are speeded up using an electric field. And as they go through the cathode ray tube, they get projected horizontally because of the electric field, which acts on the charge of the electrons. Okay? Or because electrons are charged particles. So here we have to just worry about the projectile motion of the electrons. Okay. So they are projected at a horizontal speed. So your initial velocity is u I cap, where the value of u is this much, into a region between a pair of plates which is 2 centimeters long. It's like, let's say this is one plate, and this is another plate, and this distance between them is known to us. It is 2 centimeters. Now imagine an electron which is getting projected from this plate at a horizontal speed u. So it'll end up going on a parabolic path like this. Okay. So there is an electric field between the plates which exerts a constant downward acceleration on the electrons of this much magnitude. So this time the only difference is that the downward acceleration of the electrons is not equal to g, but it is equal to this value, 10 raised power 7 centimeters per second square. So to re-derive the equations, okay. So if you take the horizontal axis as your x-axis, the downward axis as your y-axis, at any given time, your x will be ut, but your y will be half at square instead of half gt square, where the value of a is like this. Okay. So by the time the electrons reach here, if this vertical displacement is d, small d, let's say, so capital D is equal to ut. From this, you find the value of time, and then that small d becomes half at square. So from this, you find the value of small d, the vertical displacement. That will be a small d. And the velocity as it emerges, so the velocity will become u I cap plus some vertical component j cap, and that vertical component will be at. So a is given to you, and t you have calculated from this first equation. So this equation is becoming like this: 2 centimeters is equal to, what is the projection speed now? 10 raised power 9 centimeters per second. into time. So you can see the time is 2 nanoseconds. Okay. So in 2 nanoseconds, how much is the vertical displacement? It will be half into vertical component of acceleration, which is 10⁻⁷ centimeters per second square into 2 nanoseconds squared, which is a very small displacement. It will be 2 into 10⁻⁻18 plus 7. So that's minus 11 centimeters. This will be the vertical displacement. Okay, very good, Yash. Okay, so that's the only difference, that instead of G, now it is a different acceleration because of a vertical electric field acting on the electrons. Rest of the things are the same. Okay. So I think with this, we complete the doubts, as well as we are out of time. It's 1
Yes.
o'clock. Okay. So very good. So next time we will start relative motion. So in the meantime, as I told you, I'll give you another revision worksheet. In fact, couple of worksheets. One will be for revision of projectile motion questions, and one will be for advanced revision of 1D motion questions. Okay, because you also have advanced pattern question paper coming up for the next major test. I'm sure all of you are aware of this.
Yes,
The
sir.
major test that you'll have on 19th, it will have 2 papers of 3 hours each. Of course, there'll be a gap between the 2 papers. It's not continuously 6 hours. So paper 1 will be your regular JEE mains type questions, which you're seeing. So 20 single option questions and 5 integer answer type questions per subject. Paper 2 will be a JEE advanced pattern question paper, which does not have any fixed pattern, but there will be sections which have more than one option questions, then matrix match questions, and paragraph questions.
Sir, the questions which will be asked from kinematics will be like the questions which you give in worksheets, or it will be different.
Yeah, worksheet as well as module. Okay.
Okay, sir.
Particularly for JEE advanced pattern, you will see that the module exercises have particular exercises with more than one option question correct, with matrix match, with comprehension.
Yes, sir.
So the level of the questions, the concepts will be the same as the exercises which you're doing, but
So-
particularly for the pattern, refer to the module exercises. That is the best place. Yes.
So,
Yes.
sir, in the test, in both the tests, means what will be the portion?
The portion from kinematics beta is 1D motion and projectile motion. These two.
And
things.
relative portions?
Relative motion will not be there in this upcoming test.
Okay, sir. And sir, the couple of worksheets which you are giving, what if we
Yes.
have not sufficient time to finish the worksheets then?
No, by 19th you have to do na beta. Okay. It's like you have plenty of time. Na? Today is only 7th.
Okay, sir.
Plus we'll have some additional doubt sessions also. Na? Like this week also we have some doubt session planned. So we have to complete those worksheets. Okay. For the best result in the test, we have to complete the worksheets.
So I believe the 15th means I believe the Friday doubt session is cancelled because the Ganesh.
Ganpati, na? So it will get rescheduled. Na? Don't worry. It will get rescheduled.
Okay, sir.
Okay. They will be rescheduled. Okay. Okay.
Okay, sir. Thank you. Thank you, sir. Bye, sir.
Okay. Bye. Bye.
Thank you, sir.